My name is Zac Sweers. I am a mobile engineer at Uber. If you haven't heard of us, we are a local startup focused on moving people and things. We have about 300 mobile engineers at the company, and I work on a team called Mobile Platform, which basically is a group of iOS and Android engineers that try to support all these developers in the company with internal frameworks, architectures, things like that. And what that means is the things we build need to scale. Now, I'm not talking about working on X number of devices or an X number of countries or anything like that, but rather from a developer experience standpoint. What we build today needs to work tomorrow, next week, next month, maybe next year. But we're working on thinking that far ahead. For hundreds of developers on dozens of teams. And the reason we need to do that is because if we don't, then they won't use it. Now, what do I mean by that? So here's sort of the meta question of all this. What makes an API? Or more specifically, what makes an API bad? And the metaphor here is that it's art. So what better way to talk about art than with more metaphors? So this is one of my favorite metaphors. It's actually used for UI and design to talk about the difference between what you think is good design and where you want to take the experience and where the user experience actually goes. It's about how you work with or how people interface with what you build, and developers are users too. And I think that you can actually make this analogy fit pretty nicely here. And as users, they're going to optimize for their own efficiency. There's different flavors of this as well. Here, it's taking shortcuts to what they're trying to do. It can also be about avoiding unnecessary ceremony. Sometimes they can't even tell if your API does what they want it to do, but they know where they want to go, so they're just going to walk that way, and maybe somewhere in the distance it actually turns right and ends up with what they want it to do, but they can't see that up front. How you handle these cases is really up to you. There's good ways, there's bad ways, and the wrong ways in particular I want to highlight here. One is docs that pretend it's not an issue and just say, oh, you're supposed to go this way, and ignore that. Or in even worse case, the docs that acknowledge that it's a problem and ask you to please not do that anyway. What I really like about this is there's this person walking in the bushes over there who's given up on both forms here. So I think they're probably a QA engineer or something. And in the worst case, you just don't let them go that way. That there's stuff in there, but you're just not allowed in. So those are, I think, some good metaphors of what makes an API bad or signs that you have some issues with it. Now the flip side of this is what makes an API good. Who here knows a good API when you see it? That is 2 hands. Who here knows a bad API when you use it? Exactly. All right. So what makes a good API? It's a lot harder to recognize because a good API often reveals its value by how often you do or don't have to think about it. And one thing that I think does help with this, though, is to think of it as a tool. A good tool is often sort of limited by design and sort of focuses on doing one thing really well. This is a hammer. It's obvious what it's for. The scope is limited to just a few functions for it that it does really well. At the same time, it is a little bit flexible to how you can use it. Users can customize the grip that they use, the weight of the head, the material that they want to use for it, depending on the nails. But the purpose is still singular. There's some customization for it, but it's still just for hitting things. And you have to assume that your tool is going to be used with myriad other tools that you don't know anything about. There's this old expression that a carpenter is as good as their tools. And whenever you go, who here had a parent or grandparent who had a garage full of 8 million tools? Oddly, this half of the room. And these tools, whenever you see them, they really tend to be sort of an orchestra of different good individual tools that work together rather than one sort of super tool that does everything. And there's a lot to be said for libraries that work well within an ecosystem rather than expecting other tools to accommodate them. This also helps keep the library focused, and you're not trying to write Python. I don't know if it's a good example of something that does everything. C++. So as a case study for all this, we're actually going to spend most of this talk doing a deep dive into the various iterations we went through for a library we wrote called AutoDispose. Now, quick bit of background here and timeline. Our AutoDispose is an RxJava 2 utility for automatic stream disposal. It was originally built in a side project in October last year, mainlined into Uber in December, and open source finally in March of this year. The example, it is specific to RxJava, but I'm going to try to keep it at a high level and focus on the API semantics of it. Who here has used RxJava or is familiar with it? Okay, all right, I feel pretty good about this now. So what are we trying to solve with this? So here we have just like a plain old observable. It synchronously just emits 1 whenever you subscribe to it, and you're sort of done. Now, say we make this a network request whose results we're listening to. Things immediately get tricky here because network I/O takes a long time. And you shouldn't do this synchronously. And in fact, on Android, it won't let you either. It'll throw an exception at you. So we would need to do this on the background and observe on the main thread for the result once it actually comes back. Now, this is great. Rx is really powerful and really useful for these kinds of situations, and it makes it much easier to reason about your threading model here. But now, Android gives us a new set of problems here, which is that, say we're running this in a detail activity of some sort, and what happens if the user presses back? If the request is still in flight, we now have a memory leak. We can prevent this by unsubscribing. In RxJava 2, this pattern is represented in the form of a disposable that it gives you back whenever you call subscribe. And you can basically just call dispose on that whenever you want, and that will cancel the in-flight request if it's a network request, or, well, actually, it depends on the library. But that will cancel the ongoing stream. And assuming that it has cancellation wired up internally correctly, it should, clear up state. So we want to handle this automatically. And if you're familiar with lifecycle management in Rx, then you'll know that there's already a lot of solutions out there, like using composite disposable or Rx lifecycle. And this talk isn't about which one you should use or how AutoDispose compares. If you're interested in that, there's a long section in the README. We're going to focus on the API. So what does AutoDispose look like when we use it? Well, for starters, it automatically handles disposal, so we can chop that off. To wire it up, we actually leverage RxJava's to operator. There's a few other operators, but I'm going to have to put them in quotes because it's weird to say otherwise, which lets you convert a stream to something else. So whenever we use this, we end up with an API that looks like this. And that's sort of it, at least for the scope of this talk. To break this down a bit more, AutoDispose itself is just a class with factory methods on it. We'll get into this a little bit more later. This with API is just something that takes in a scope and then returns a sort of intermediate scope handler for you to then tell it what type you want an instance for. And this is actually sort of a weird, I think, in my opinion, hole in RxJava's API, which is that we have to specify this type every time because every overload of this only takes the same function type for it with different type parameters, and Java doesn't know what to do with that. So if it was like a different interface, then you can make like a composite one and it works really nicely, but we can't. There's the first API lesson. And that's roughly how they all stitch together. To explain a little bit more about how scopes work, there's basically 3 different kinds. The most basic version is just a maybe. This is sort of what every scope eventually whittles its way down to. It's something that might emit to tell you, hey, like, scope's ended, dispose yourself. Or it might emit complete to say, like, you're unbound, go nuts. In our example, we have this, which is a little bit more abstract. And this is actually probably the most common use case that we have because this might be like an activity or a fragment or a view or something that implements one of 2 interfaces. The first is a scope provider, which is just a simple interface that can return a scope when requested of it. And this is a sort of light abstraction as a scope can be deferred to whatever parent context. So like an activity knows when it's going to be destroyed. So an activity can say, hey, like I've got some wiring internally that I can tell you whenever I'm going to be destroyed and you should clean yourself up. The more complex abstraction is lifecycle scope provider, which is basically more sugar on top of what we had before, but this actually lets you sort of define like beginning and end boundaries of your scope, usually associated with a lifecycle, so that you can say, hey, like if you're trying to subscribe after onDestroy, I'm going to throw an error at you. Or if you are in like a view and you try to subscribe in the constructor when you want to actually make sure that you're waiting until like attach or something, you can throw an error at them there too. Yeah, so this could be an implementation of either of these, passed in, etc. And under the hood, these all just resolve back down to a maybe. And internally, under the hood, we just subscribe to that maybe. When it emits, we say we're done, dispose, and that's it. So how do we arrive here? We probably rewrote this from scratch like 6 times. And I'm not going to get too much into like the implementation details under the hood of how the mechanics of the subscriptions under the hood work. But focusing on the API, like, this is really what we wanted to get right in this, because everything that we had tried up to this point just had, one big caveat that, made things really messy for everyone. So going back to October, this was sort of the state that we were in. We had, an API request, subscribe on background thread, and observe on the main thread, and subscribe. Now, I've been doing reactive lifecycles for a while, and we knew that we wanted very specific things out of this. It needed to be disposal-based. It needed a dead simple API. It needed to be automatic in some fashion, or be able to give some sort of abstraction to say, hey, like, you don't know about how my lifecycle works, but I'm going to be able to tell you when you should stop. And also boundary checking. And some early prototypes were actually trying this out in Kotlin extensions or extension functions. So this was one that just on a disposable, you could put a dispose on extension function and give it a lifecycle, and then it would have a reference to that, and then just call dispose whenever it was done. This didn't seem that crazy. Look how concise it is. It's it looked nice, but then what happens if you try to do anything else? So here, like, we actually start implementing subscribe. There's some stuff in there, still not too bad. What if we start putting a whole bunch of stuff in here? Now you're actually like, you're thinking about what's in the subscribe method, and that's, the important part. But now we've actually forgotten the dispose on method here. That's a very easy mistake to make, because that's not the important part here. The important part is whatever you're doing in your subscribe implementation. So we put that back. But now, what about some other cases where, say, we're using different overloads of subscribe that get a little bit harder to read at it, or the real problem with this, or one of the real problems with this, what if we actually don't automatically subscribe, like if we use delay subscription? So whenever we call dispose on, that all happens synchronously, because the only reference that we have is this disposable object. And what happens is that whenever onSubscribe is called, if it happens synchronously, great. If it doesn't, we're only binding to the lifecycle at the exact time that you created this entire stack. So this is actually just fundamentally broken here. The other fundamentally broken bit is if you try to pass in a full-blown observer into it, the signature for that method is just void. So you've actually got nothing in here to hook into. So that doesn't even compile. And it also turns out that using this as an excuse to migrate to Kotlin doesn't work on managers. Hi, Luke. So back to square one. We knew that we wanted to do something that would decorate an existing observer because we wanted to be able to hook into those onSubscribe points. And so we basically did a bunch of work and ended up with a V1 that sort of looked like this. We had, and for brevity, I'm going to just focus on the subscribe bit here. So what's going on with this? So we had a custom observer factory called bound observers that would just dispense a creator, kind of like a builder. I don't know why I called it creator. It's a builder. For actions, they would take a scope, and you'd have to specify the generic here because Java-C, I don't know why I just wasn't smart enough to know what you meant. And you'd have to type the whole type, so like for observable, and then you could add consumers for the different actions that go into an observer. So like on next, on error, etc. And then you just built it at the end, and that was it. So does this work? Yes. Oops, wrong button. But at what cost? So the first thing you'll notice is that this is really long. And screen real estate is actually precious in the context of readability. Another is sort of the ceremony involved in this. So my observer's a creator now, and what that means is that I always have to call create, which is sort of fine as I'm running through here. It's not terrible, but what if I want to use the noarg subscribe? Yeah, we still have to do this. And that's just, it's annoying. And another annoyance that came out of this is that the generic here wouldn't actually autocomplete in the IDE. Again, no idea why, but it would never really work. Or rather, I find out why later in the talk, spoiler. So it's a little thing, but when it's gone, the type gets erased, and now the developer always gets burned after the fact down here whenever their type is an object, and they're like, what is going on here? So it's lost time because they have to go manually add the generic again, and then go back and fix the code that was just auto-completed incorrectly for them. And yeah, it's just more friction on there. The last issue, though, is a bit more serious. What if we have a custom observer implementation? Creator has no support for this. It just took consumers. One solution is to require a custom observer to extend our bound observer. Not ideal, but it works. Does it always work, though? The answer is no. What if we actually, so if we control the implementation, it's manageable. But if we don't, such as like an Rx Java subject, we've hit a wall again. Now, how can we handle this one? Well, what if we take an observer and just delegate to it? So we just write this, around method, and it takes in an observer and just, says, I've got stuff, and I'm going to send it to you. Does this work? Yes, but we still got those other APIs in here. And this is actually sort of a given with builders, but it also is sort of against the grain of how people think about Rx. Like, you never say, like, I have an on next here, and I might override that later with something else. And it's sort of, it was just weird to try to stuff a builder into this. So, and you could actually go really crazy with this, as something like this was totally legal. Yeah, so we have some issues. But remember, the core of this actually we know works now. So the real question is, can we fix the APIs around this? And the answer is yes. So first things first, we renamed it to AutoDispose, and yeah, that was easy. API design, picking good names. The next bit is to try to take on that creator bit. So this around method actually worked really nicely with observer and matches the Rx subscribe signature as well. Why not just do that for the other cases as well? So, and I've omitted some here, like some of these return observer, or some of these return disposable, some of these return nothing. It's, yeah, I omitted for space here, but yeah, so now there's no builder involved. Each of these is terminal, so you can't keep calling it multiple times with different values. What about the empty case that we mentioned earlier? We'll just tack that on, it's fine. And this wraps it up nicely into actually an interface that we can return from higher up in the code and be able to push whatever extensive state or implementation details that we want behind it. So now we have the sort of parity with the Rx subscribe APIs in this around clause, and it keeps things a little bit familiar for users. This was a pretty significant rewrite of the internals, so we're going to go ahead and call this basically like V2. Next part was making the scope obvious. So right now we've got sort of we have this sort of life cycle being passed in over here that and so we want to try to make this more obvious. So this is the scope that you're binding to, and we extracted that to an intermediate clause to make it explicit with this scope with method. So yet again, this actually required a bunch of plumbing changes under the hood. So we'll call this V3, and this also made it really about scopes and not just life cycles. Next on the docket that we have is that generic that we were trying to fix up. Now, what do we want out of this? So first and foremost, we want auto-completion, because if that's not working, then the whole thing is just a huge pain to use. So we want to fix that. The second option, or the second goal, if possible, is to make the generic sort of optional or inferred, especially on Java 8 where things are a little bit more intelligent about it. Yeah, so taking a step back, like where does this generic matter? On the factory? Okay, so what about the scope width clause? Still no, it's actually just returning an around clause. So actually, this finally just leaves us with the around interface that we defined before. Now, the signature of around up to this point had been on the signature involved having the generic on the type itself, and then that was sort of passed down to the methods there. But does it need to be on the type? You only really care about it at the site target, so and not the class itself. Like it's not like you're going to call this later, and you want to make sure that every time you call these different overloads of around, you have the same type on them. So we can actually just move them directly to the function and defer to the argument to provide the type, and that actually makes this a lot easier for us. So now, whenever we call this, it just defers to whatever was passed into around. I'm going to switch to Java here for the example. Yeah, since the generic is, switching to Java because the generic is more of an issue there. If you're doing this in Kotlin, which my earlier snippets were, it's easier, like most things in Kotlin. So now that we have this, we're in business. The generic is actually handled by what you pass into around. Here it's actually inferred from the response observer that was already typed, but we can also do this with anonymous moving to RxJava 2 internally. So this is about December or so, and we had basically this build train freeze where we don't release for a month. And so some people say, oh, well, vacation time. And a couple of us said, well, we'll just do all the dangerous migrations we want to do now while we've got time to let it incubate. So we did that. And that was basically what we had in place for about a solid month and a half. Now, are we done with this? No, we've solved the autocomplete issue, we've solved the creator, we've solved the naming, but we actually still have a decent amount of ceremony involved here. There's a lot of cruft under the hood with how we have to handle exceptions, because a lot of RxJava's internals have exceptions. If you were to stop in the middle of it, it doesn't do anything. It's just sort of it's a Fluent API that you have to call the same 3 methods every time. So we want to try to improve this. So now if we actually go through and implement this consumer, especially in Java 7, you start to see a new problem. Do you see it? We're sort of indenting our way across the universe. And this was actually a really big issue. It hurts readability, it's annoying, it's ceremonious. Going back through and we were doing a migration for something later, I actually saw a bunch of those response observer classes, which was just a static inner class, and I wondered why is everyone always making a new class? And it was because they literally couldn't fit the generics on the line width requirements that we had. So we did this for, like I said earlier, for about a month and a half, but we wanted to make it better. So at some point, I was on a plane and I was running around the Rx shop or the observable source code. I don't know why I was there, but I was there, and I came across this to operator. And I'm looking at it, I'm like, this is actually, sort of like a light bulb moment. This is perfect for what we want. So to is neat. It lets you convert anything in the chain to something else. That something else is totally up to you. It just gives you an observable, and then you can return something different. You can choose to throw the observable away. You can convert it to a custom observable. It's totally up to you. So what if we made this return the around clause that we had mentioned earlier? Now we can actually take back space in our setup by finagling this function into here and moving the rest up. Now to make this work, what do we have to give to 2? Well, what if we just made that scope width method just return an implementation of that function we were looking at before? Does this work? Unfortunately not. And this is because generics are biting us here again as the types are erased yet again. Which is really frustrating when it happens. That's I didn't realize that was such a big deal. But yeah, so this happens, breaks things again, people are unhappy. So we need to put the types into the toSignature to pass around, and because we can't basically, the compiler can't infer it, the compiler can't infer it from outside the context of that around method that we had before. So, because the around method was being passed into the subscribe method, and it was somehow connecting the dots for us there in a way that it can't now. So how do we handle this? Well, the static API isn't viable because of earlier autocomplete issues that we mentioned, so we need to do something else. And it turns out that if you new up a new instance, autocomplete works just fine. So we created this scoper class that just implements that converter function. It takes in a scope as a parameter, it implements the apply function, and just returns a new instance of that around clause with all these scope handling mechanics baked into it. Under the hood here, we just are calling subscribe to the observable that we got. And what's neat about this is that we can actually pass this subscription directly onto RxJava, but decorate it first in our own custom observer. And what this is useful for is that we can actually start reading information back from RxJava. So like there's a new API in RxJava called Lambda Consumer Introspection that will be able to tell you if RxJava's built-in observer is going to throw a on error not implemented exception back at you. It's sort of like some nice wins that we were getting out of this by not doing the work ourselves. So we've got a new problem here, though, and that's that the generics that we put on those methods earlier are now useless again, and we need to actually propagate this at the type level. So now we're going to undo all the work that we just did earlier because the paradigm has changed, and we need to adapt to that. So now we're going to make the around clause generic again, and we're in business again. So now we've got autocomplete. It looks like you're actually sort of not breaking the chain. It's actually quite nice. We're shortening the code. Can we do more? Yes, we can. So one sort of awkward thing about this is that we've lost the notion of subscribe. Like everyone, whenever they're working with RxJava, they're like, okay, observable this, and then subscribe at the end. And now at the end of this, we have around, which you might know how it works under the hood, but it's not obvious from looking at this that that's the behavior going on here. It's weird. So looking back at this around clause, the implementation now is actually, we know under the hood it's just a proxy to subscribe. So what if we just make that explicit? No, really, like all these methods are just proxies to subscribe, and they all match the RxJava subscribe signatures, including you. And we can actually take this and then when we use this back in our normal code, it looks like this. And now we're really starting to get back to what looks like very vanilla Java. Sure, we're faking the subscribe here, but remember the metaphor for this is art, and like art, if it looks right, it is right. So this constituted what I'd call sort of like V5. It stayed like this for a long time, about 8 months or so, but still sort of itching to try to make that converter function a factory. There's a few reasons for this. It's easier to change implementation details under the hood. You get some, I think, readability wins. And also, like, what is a scoper? Like, no one looks at that and immediately knows what that's supposed to be doing. So fast forward to about, like, September, I started doing a bunch more research to try to figure out why autocomplete doesn't work whenever I use the static APIs. And the answer, after a bunch of debugging with this, it works if you have no parameters. This is in IntelliJ. It works if you have no parameters. It fails if you do have parameters. Doesn't matter if the parameters are generically typed or anything like that. It's just how it is, which I thought was weird. But okay, now I actually know, if I have no parameters, then the IDE will autocomplete it for us. So we can swizzle this around, and we can say AutoDispose.width with the scope, and then on the type sort of output for that, you have no parameters, and then the IDE autocompletes it for you. I had no idea why this was the case, but it worked. So accounting for that, this actually worked out really nicely. And in Java 8, you don't even have to specify it. Now we're with this. It's still a little bit ceremonious because you're having to do with scope.forType, and you're going to have to do that every single time. The indirection might be nice in the future, but right now we don't do anything with that other than just service back a scope handler. And what we'd really like to be able to do is something like this. But the auto-completion story isn't there for the reasons mentioned before because of Java 7. So debated on whether or not to go 1.0 with the two-step walkthrough. And then I went to droidCon New York last month, and I was talking with someone about being stuck on this piece and how the IDE wouldn't autocomplete in certain situations, and she says, "Have you reported an issue?" She is a genius. And so that's what I did. So I opened this issue, detailed everything in there, gave a sample branch from AutoDispose. This was on October 1st, and it was fixed on October 4th. And it was released in the IntelliJ 2017.3 early access on October 13th, and it'll be in the final release and Android Studio sometime after that. So we might wait for that before we go 1.0 on this with sort of one last API change. Or we might go early with Java 8 and the expectation that everyone just uses D8 and we avoid this issue entirely. Is it done? Probably not. But I feel pretty good about this. Yeah, so which brings us sort of back to our meta question. And the answer is that it's still hard to say. But for the sake of giving some pointers and at the risk of some subjectivity, I'll leave some, I guess, high-level learnings from this. So first one is prefer exposing interfaces. Now, what I mean by this is particularly in a factory setup, you can hide tons of implementation details in this in a very safe way. And it's not necessarily even just about hiding these from consumers, but it's also about not tying yourself to whatever consumers were using before. So like in the scoper example, any changes we wanted to make in that had to go in the scoper class. But by being able to return an interface, we can actually return totally different implementations under the hood, depending on whatever conditions or context we might have there. This also applies for the subscribe proxy. Yeah, it's super useful. The next bit is preferring composition in accepting external implementations, and that inheritance can be inconvenient. Now, I know that sounds like a really wordy way to say composition over inheritance, but stick with me. So, this is a nuance of that argument, but specifically what I want to highlight here is that by accepting just interfaces, whenever you're saying hey, give me an implementation of something that I can work with, you're being flexible to the user's needs. So we don't have AutoDispose activity, we just have scope provider or lifecycle scope provider. You can make whatever you want, implement that, and then we can piece the things together. Because if we did have our own AutoDispose activity, probably no one would use it because everyone's got their own base activity. Inheritance can be really inconvenient for your consumers. It also keeps your logic agnostic to implementation details. So if you give it a full-blown class and say, give me subclasses of this, you might know certain things about how that works under the hood, but is that always the cleanest approach? Maybe, maybe not. And by working with interfaces, you have to be defensive against behavior and trying to logically define how you want this to work at the API level rather than just relying on implementation details. The next one is preferring final over default. So this is, again, sort of part of the usual composition over inheritance bit, but I think this is also important with regards to sort of limiting API surface area and letting the compiler enforce these semantics for you. By making things final, you're literally saying you cannot compile trying to override certain things here. This is all the things that I have exposed to you, and you have to run with this. There's also a testing component to this, which sort of comes indirectly, but there's always someone that comes in and says, well, static and final APIs make testing really hard, Mockito doesn't know what to do with it, et cetera. And that's true. And I'm not saying that you should never use Mockito. Someone's going to come up to me after this anyway. But what I would suggest keeping in mind is that if you can't verify the correct behavior from your public API, then neither can any of your consumers. So just something to keep in mind. Identify foot guns early. So when I say foot guns, who here knows what a foot gun is? Okay, so a foot gun is a gun that whose primary purpose seems to be shooting yourself in the foot. So Java's full of these, and this is also a good one. So it's it's almost never the right thing to do, and you want to try to prevent it. You're never going to be able to fully spot all these. A lot of them are going to come up retroactively as people start to use your library. But if you can spot these early, you look at this and you know that it's really tempting to do the wrong thing here, then you should try really hard to make that not an issue. Dependency on lint should be avoided. So for those of you that went to Brian's talk just before this, he said we have a error-prone checker that requires you must use AutoDispose, and that's true. I think that lints are really useful for cases where at like a macro level you want to say like a blanket requirement, all of these conditions must be met, or you want to block certain known bad classes, things like that. But what I'm getting at in this point is that if your API requires a lint rule to make people use it correctly, maybe it's time to reconsider it. Yeah. The last thing, and a good API, ideally should be coercing the user into doing the right thing more often than not. The next one is IDE experience matters. So what I mean by this is, what we were talking about earlier. Like readability is super important. Auto completion and gotchas are super important. If people run into a lot of friction with this using your work, they're not going to want to use it. It's super frustrating for a consumer, and it's super frustrating for a library developer too, because they're like, well, it works, but the answer boils down to I don't want to use it. And the last thing I want to touch on is crack eggs and make omelets. Start with a minor version whenever you release something, and sort of work at it as long as you need to before you commit to a stable API. Like art, you work at it. You can be sculpting it. You want to account for use cases that you have today, but that might come up later in the future as well. And coming full circle, some of that requires awkward APIs in the future, where you say, you know what, I built this nice API here, but everyone clearly wants to go this way. Maybe that building wasn't there before. Maybe it's, I don't know, smells bad over there. Yeah, it's, things change and you need to be reactive to it. And sometimes you might have to just make a new path into your existing API. Sometimes you can do that elegantly, sometimes you can't. Change happens, and as long as you're reactive to that, you'll continue to maintain a good working relationship with the consumers of your library, and your API will be better for it. Might not be perfect, but you can try your best. And that's it. Thank you. Any questions? Oh, sorry. The question was, do I have concerns about backward compatibility? The answer is yes. So once you commit to a stable API, if you really want to keep that trust with your users, you need to commit to that. And so I'm a big proponent of starting with a non-stable API release, like 0.1.0, and then just iterating on that for as long as you think you need to for it to get to a point that you're happy with. So AutoDispose is well over a year into work now. We're still not 1.0. And then once you do go stable, it depends really on sort of the size and usage of your library. If you're something like RxJava, it makes a lot of sense to go through and actually change your entire Maven coordinates and package names so that you can use them side by side. If it's an internal library and you can just migrate things in one go, that's definitely how we have handled these iterations internally at Uber. You have to, you have to pick trade-offs. I'd say once it's out in the public and you don't know who all is using it and it's a significant enough library, I think actually the renaming packages and coordinates actually works really well. Any other questions? Cool. Thank you.